A reusable launch system is a launch system which is capable of launching a payload into space more than once. This contrasts with expendable launch systems, where each launch vehicle is launched once and then discarded. No completely reusable orbital launch system is currently in use. The closest example was the partially reusable Space Shuttle. The orbiter, which included the Space Shuttle main engines, and the two solid rocket boosters, were reused after several months of refitting work for each launch. The external tank and launch vehicle load frame were discarded after each flight. However, several at least partially reusable systems are currently under development, such as the Falcon 9. Orbital RLVs are thought to provide the possibility of low-cost and highly reliable access to space. However, reusability implies weight penalties such as non-ablative re-entry shielding and possibly a stronger structure to survive multiple uses. And given the lack of experience with these vehicles, the actual costs and reliability are yet to be seen. History. In the first half of the 20th century, popular science fiction often depicted space vehicles as either single-stage reusable rocket ships which could launch and land vertically, or single-stage reusable rocket planes which could launch and land horizontally. The realities of early engine technology with low specific impulse or insufficient thrust-to-weight ratio to escape Earth's gravity, well, compounded by construction materials without adequate performance and low weight, seemingly rendered that original single-stage reusable vehicle vision impossible. However, advances in materials and engine technology have rendered this concept potentially feasible. Before VTVL SSTO designs came the partially reusable multi-stage Nexus launcher by Kraft Arnold Erika. The pioneer in the field of VTVL SSTO, Philip Bono, worked at Douglas. Bono proposed several launch vehicles including Roost, ROMBUS, Ithacus, Pegasus and SASSTO. Most of his vehicles combined similar innovations to achieve SSTO capability. Bono proposed plug nozzle engines to retain high specific impulse at all altitudes. Base first re-entry, which allowed the reuse of the engine as a heat shield, lowering required heat shield mass. Use of spherical tanks and stubby shape to reduce vehicle structural mass further. Use of drop tanks to increase range. Use of in-orbit refueling to increase range. Bono also proposed the use of his vehicles for space launch, rapid intercontinental military transport, rapid intercontinental civilian transport, even Moon and Mars missions. In Europe, Dietrich Oel, inspired by Bono's SASSTO design, proposed his own VTVL vehicle named Beta. Before HTHL SSTO designs came Eugen Sanger and his Silber Vogel suborbital skip bomber. HTHL vehicles which can reach orbital velocity are harder to design than VTVL due to their higher vehicle structural weight. This led to several multi-stage prototypes such as a suborbital X-15 aerospace plane being one of the first HTHL SSTO concepts. Proposals have been made to make such a vehicle more viable, including rail boost, use of lifting body designs to reduce vehicle structural mass, use of in-flight refueling. One of the few HTVL vehicles is the 1960s concept spacecraft Hyperion SSTO, designed by Philip Bono. X-20 Dinosaur is an early example of a VTHL design, while the HL-20 and X-34 are examples from the 1990s. As of February 2010, update. The VTHL X-37 has completed initial development and flown an initial classified orbital mission of over 7 months duration. Currently proposed VTHL manned spaceplanes include the Dream Chaser and Prometheus, both circa 2010 concept spaceplanes proposed to NASA under the CCDEV program. The late 1960s saw the start of the Space Shuttle design process. From an initial multitude of ideas, a two-stage reusable VTHL design was pushed forward that eventually resulted in a reusable orbiter payload spacecraft and reusable solid rocket boosters. The external tank and the launch vehicle load frame were discarded, and the parts that were reusable took a 10,000-person group 9 months to refurbish for flight. So the Space Shuttle ended up costing $1 billion per flight. Early studies from 1980 and 1982 proposed in-space uses for the tank to be reused in space for various applications, but NASA never pursued those options beyond the proposal stage. During the 1970s, further VTVL and HTHL-SSTO designs were proposed for solar power satellite and military applications. There was a VTVL-SSTO study by Boeing. HTHL-SSTO designs included the Rockwell Star Raker and the Boeing HTHL-SSTO study. However, the focus of all space launch funding in the United States on the shuttle killed off these prospects. The Soviet Union followed suit with Buran. Others preferred expendables for their lower design risk and lower design cost. Eventually the shuttle was found to be expensive to maintain, even more expensive than an expendable launch system would have been. The cancellation of a Shuttle Centaur rocket after the loss of Challenger also caused an hiatus that would make it necessary for the United States military to scramble back towards expendables to launch their payloads. Many commercial satellite customers had switched to expendables even before that, due to unresponsiveness to customer concerns by the shuttle launch system. In 1986, President Ronald Reagan called for an air-breathing scramjet plane to be built by the year 2000, called NASP X-30, that would be capable of SSTO. Based on the research project Copper Canyon, the project failed due to severe technical issues and was cancelled in 1993. This research may have inspired the British HOTOL program, which rather than air breathing to high hypersonic speeds as with NASP, proposed to use a pre-cooler up to Mach 5.5. The program's funding was cancelled by the British government when the research identified some technical risks, as well as indicating that that particular vehicle architecture would only be able to deliver a relatively small payload size to orbit. When the Soviet Union collapsed in the early 90s, the cost of Buran became untenable. Russia has only used pure expendables for space launch since. The 1990s saw interest in developing new reusable vehicles. The Military Strategic Defense Initiative program, Brilliant Pebbles, required low-cost, rapid turnaround space launch. From this requirement came the McDonnell Douglas Delta Clipper VTVL-SSTO proposal. The DCX prototype for Delta Clipper demonstrated rapid turnaround time and that automatic computer control of such a vehicle was possible. It also demonstrated it was possible to make a reusable space launch vehicle which did not require a large standing army to maintain, like the Shuttle. In mid-1990, further British research and major re-engineering to avoid deficiencies of the HOTOL design led to the far more promising Skylon design, with much greater payload. From the commercial side, large satellite constellations such as Iridium satellite constellation were proposed, which also had low-cost space access demands. This fueled a private launch industry, including partially reusable vehicle players, such as rocket plane Kistler, and reusable vehicle players such as rotary rocket. The end of that decade saw the implosion of the satellite constellation market with the bankruptcy of Iridium. In turn, the nascent private launch industry collapsed. The fall of the Soviet Union eventually had political ripples which led to a scaling down of ballistic missile defense. including the demise of the Brilliant Pebbles program. The military decided to replace their aging expendable launcher workhorses, evolved from ballistic missile technology, with the EELV program. NASA proposed riskier reusable concepts to replace shuttle, to be demonstrated under the X-33 and X-34 programs. The 21st century saw rising costs and teething problems lead to the cancellation of both X-33 and X-34. Then the Space Shuttle Columbia disaster and another grounding of the fleet. The shuttle design was now over 20 years old and in need of replacement. Meanwhile, the military EELV program churned out a new generation of better expendables. The commercial satellite market is depressed due to a glut of cheap expendable rockets, and there is a dearth of satellite payloads. Against this backdrop came the Ansari X Prize contest, inspired by the aviation contests made in the early 20th century. Many private companies competed for the Ansari X Prize, the winner being Scaled Composites with their reusable HTHL spaceship OWN. It won the $10 million by reaching 100 kilometers in altitude twice in a 2-week period with the equivalent of 3 people on board, with no more than 10% of the non-fuel weight of the spacecraft replaced between flights. SpaceX is a recent player in the private launch market, succeeding in converting its Falcon 9 expendable launch vehicle into a partially reusable vehicle by returning the first stage for reuse. On the 23rd of November 2015, Blue Origin New Shepard rocket became the first proven vertical takeoff, vertical landing rocket which can reach space by passing Kármán line, reaching 329,839 feet. Previous VTVL record was in 1994. The McDonnell Douglas DC-X ascended to an altitude of about 3.1 kilometers before successfully landing.